panel, right?
All right. So last week, or 2 months ago, we started off down this path of let's build a very simple robot and start learning how to do that. You know, if you've never done this before, a lot of this feels very daunting, and we're trying to break it down into very simple apps to get started. Today's we're going to try to add some sensing to our robots so we can interact with our environment. But before that, let's do a quick review of what we did 2 months ago. That way we know where we're starting from. So last time, the whole mission was let's just get some movement going. Move forward, move backwards, maybe turn left, turn right. So we ran through what is now 298N motor controller. What does motor controller look like? How do you control those and get it running? So if we go look at the code real quick, we set up some very simple functions: move forward, move backwards, stop, curve left, curve right, turn left, turn right, with some values. And then if we were to run this program, here is our little robot. I'm going to go ahead and hit run on this. Okay. Correction. And the motors move. As always, Jocelyn are. I even re-crimped all of these last night. You know, because I had been waiting for 2 months, so I did it last night.
Better man than
Okay, so going back to the code that we did last month. Here. We declared some pins for our motors to move forwards, to move backwards. They are PWM. We talked about what that was. We set a frequency, how quickly we are talking to these devices, and we ran through and made it produce the motion. So today we're gonna, like I said, we're gonna try to add some sensing. And what are our options? There's all kinds of options that our robot could do to sense the world around it. And so light sensing, you know, following lines, moving towards a light, GPS, you know, where are you in the world? Vision with cameras, LiDAR, with lasers, all sensors and bump stuff, you know, just like your Roomba would, bumps into something, it stops, changes directions. And there's so many different options of things that it can sense. Today, we're going to actually take a very simple sensor and use an ultrasonic sensor. Ultrasonic sensor is just it's going to send out a sound pulse and listen for the echo. And so with that, we can use sound waves to calculate a distance for that. So today's mission, let's sense the distance. If we run into something or we feel like there's something in front of us due to that echo, let's look around, see if there's an option. If I turn left, turn right, use that motion that we produced last month or 2 months ago. And then choose which direction is open, turn that direction, and let's control that move. So before we get started, let's talk about what we're adding this month. So we're adding a servo because we want to be able to look around, and we're adding our ultrasonic sensor. So we're going to use a very simple MG90S servo, cheap servo. You can get them dime a dozen. And I will warn you, the cheaper you get, the more quickly they wear out. But they're so cheap, you just throw the next one in and you're good to go again. The servo is just a very simple motor that it has very precise control of where it's going to move. And so when you tell it that you want it to move in a direction, you're going to give it a point and it's going to go to that exact point or close enough. With a servo, you have 3 wires that go to it, a power, a ground, and then a signal wire. The signal wire is where you're going to send that value of where you want it to go. The ultrasonic sensor has 4 connectors going to it, power and ground, just like the servo does, but a trigger and an echo. So it's got basically a speaker that's going to send out a pulse and a microphone that's going to listen for that pulse. And so those 4 pins will get wired up to our controller as well. So like I said, the goal is to stop when something's blocked, turn in some direction, and then continue in the open direction. So from that, I'm going to transition over to let's look at some code and see what we can do. Whenever I go through a lot of figuring stuff out, I like to break things down into simple tasks. Let's focus on one at a time. Let's get that working and prove that that can be accomplished. And then we'll move to the next one. And that's how you kind of build up on a big program. Okay, so if we come back over, let's start off with, let's use our ultrasonic sensor to sense the world, calculate a distance. So I pre-wrote all this code so you don't have to sit there and watch me type all of this like we did last time. But let's walk through it anyway, so everybody kind of gets an understanding of what's going on here. So again, I'm going to kind of skip over some of the things that we learned last time to speed this up a little bit, but we are importing some packages. The tick US, so that is microseconds. And so we're setting pins 21 and 22 on our Raspberry Pi Pico as our trigger and echo pins. So that's where we're going to send and receive signals to our device. And then our ultimate goal is to calculate a distance with that echo. And so what we're going to do is we're going to trigger a pulse, so trigger a sound wave to go out. We're going to start off at 0. We're going to sleep. We're going to trigger a value of 1. So go ahead and send that sound wave out. We're going to stop for 10 milliseconds so that it continues to pulse for that microseconds. We're going to pulse for that 10 microseconds, and then we're going to stop pulsing again, and we're going to start listening. And so the next step is we're going to kind of go through the loop, and the loop is just going to continue going until it hears that echo come back.
Does the device itself create the ultrasonic sound that you have? Okay.
Yeah. So by setting a value of 1, that is telling it to go ahead and make your sound. So 0 is no sound. 1 is we're firing out no sound. Make sure that we are not producing sound yet. Wait the 2 microseconds. Go ahead and send the sound for 10 microseconds, and then stop. That way we've sent out a wave pulse, waiting for it to come back. The very next step, we're now in the echo, so we're listening. We're currently at, I don't hear anything, so that's the 0. We're going to wait until that is not true anymore. So we start hearing that pulse come back to us. We are starting, we're tracking the time in how many ticks. So that's how many clock cycles the processor is going through. we are now hearing that ping come to us. And then we are, we're gonna record when the pulse stops. So we want to know, we know that we pulsed for 10 microseconds, and that becomes, that gives us a time frame of how long we should be listening for. So taking the start and the end, we can figure out what the duration is for that sound wave. And then calculating distance, again, going back to use ChatGPT where you can. You know, you could look all this up. You could probably do the math to figure all this stuff out. Or you can tell ChatGPT how many centimeters per second does a sound wave travel. And so taking the duration, dividing it by 2, because in that the sound wave goes out, bounces back. So you only want to know half that distance that it traveled. And then divided by 29.1 microseconds per centimeter for the round trip. Get you a distance calculation. So our loop down here for our demo is it's going to calculate a distance from the ultrasonic sensor and write it out. So we're doing this in one step: print, distance, then our function call of actually producing that distance, and then just adding CM at the end. And we're going to do this 5 times, and we're going to wait 2 seconds in between each one. That way I can have time to move my hand. So we're going to test this out. Let's try to do both cameras here again. Okay, so as you can see, I have a mock sensor hooked up to our servo for later. And then this is the one that's actually hooked up for us to play with. So I'm going to go ahead and run this code. Oh, sorry. And you'll notice the distance currently is 335, 335. Now, if I put my hand in front of it, it's going to shrink quite a bit. That means that the distance is coming, or the sound wave is coming back much quicker. Okay, so we have a working distance calculation with an ultrasonic sensor. Now we have something that can be used, right? That actually works.
And it works.
All right.
One question on
Yeah.
your, on the code to wait for echo to go high and all that. So what, why is it, you're waiting until it turns 1? What does that mean? Like the echo,
So when the echo turns 1, you hear the response.
you're hearing response, but then you're waiting until it goes 0 before, before ending marking the end point.
Correct.
So that's
So,
like the end of the sound, or?
So as soon as you hear a response, you calculate, you know the distance of when it started, right? So initially 0, right? You're not hearing anything,
Yeah.
right? And then you wait for it to go. I'm sorry, that I should have prefaced. The echo is a reverse of the high-low. And so 0 is actually the high value, not 1. Okay, so
So 0 means you're hearing something?
0 means you're hearing something. No, I'm sorry. Yes.
Yeah.
0 means you're hearing something. So you're waiting for to hear something. You're marking that time of the start of the pulse. And then it will go to 1 because you're not hearing it anymore. And that's the duration of that 10.
So right, in other words, there's this multiple pulses going on in the analog world, right? And then you're catching one of them. Is this little block of code catches one of them, like, but you don't know where you are in that cycle, so it has to wait till
till the value
the last one's finished, and then hangs the one of them and stops. And it's the reverse. 0 means, while it's 0, it means you're hearing the last one, then wait until it turns 1. Now there's nothing, start the timer, then when it turns 1, stop it. And when it turns 0 again, stop the timer. Yeah. All right. That's what I thought. It's just a little side note, I guess.
Okay, so the next step in this, now we can sense something. Now what happens when we do? We kind of want to look around, see, okay, there's something, we know there's something in front of us. Is there something to either side of us? And so if we move over, let's start focusing on, let's just move a servo. You know, we already figured out the ultrasonic sensor. Let's figure out the servo. So in a very similar fashion to running the motor controllers from the previous session, we're going to, it's just a motor again, right? So the only difference is we don't need a motor controller for this because it is a PWM motor itself. So we're going to define the motor on pin 20. We're going to set it to a frequency of 50. And we're going to write some definitions for setting up the servo and looking left, looking right. So a servo typically uses, if it's not a continuous servo, uses a value of, I believe it's like 800 to 2600 or something like that. I don't know why those numbers off the top of my head. But 800 for the left, 2200 for the right, and 1500 for center. All we're trying to do is we're just telling the servo, go to this position. So that's what the set servo function does, is go ahead and transition to that number. So our demo here, look center, look right, look left, and look center. So we want to move our sensor around so that it can make distance calculations based on what's to the left, to the right, what's in front. So once again, let's pull up the camera. Okay, so now we're going to use our mock sensor that's on the servo itself. I come through and I run this code. Success! It looks left, looks right, and then go back to center. All right, so we solved 2 problems. Now it's a matter of putting it back together. Okay, so we're going to come back over to a obstacle avoidance program that we wrote. So this is just a mashup of everything that we've done before. So we have our stop, we have our move forward, we have our move backwards, turn left, turn right, curves. We set up our servo for moving the sensor around. We have our calculate distance calculations in here. And then the one big difference is when we start our program, we're going to decide when do we want it to look around. So our threshold is 20 centimeters. So if it becomes less than 20 centimeters, stop, look around, choose a decision, choose a direction, and then rotate. Okay, so our program here. Let's go through. We're going to start off moving forward. Right now, we're just going to make the assumption that there's nothing in front of us until the sensor tells us otherwise. Go ahead and start moving forward. We're going to go ahead and calculate a distance to see, is there something in front of us and should I stop? Again, a good reason to have a threshold that's not 0. We're going to go ahead and print that distance to screen just so we can see the calculation. And then we're going to decide, are we within our threshold? Should I stop? If we are within our threshold, I'm going to go ahead and call the stop function that we did 2 months ago. We're going to now tell the servo to move the sensor to the right, to calculate a distance there, to see, could I turn right and move without hitting something? If the threshold, if we're outside of the threshold, let's go ahead and turn right again, a function that we wrote 2 months ago. We're gonna stop. So we're gonna rotate right for 1 second. We're gonna stop. We're gonna look center, and then we're going to loop again.
Aren't we already stopped?
We are turning right. And so that's gonna continue turning right for 1 second,
Gotcha.
and then we're gonna stop turning right.
Got
So
it.
that we are now ready to move forward. Okay. We're gonna look left. We should see that the distance calculation is blocked because that's where we just came from. And then we're gonna go forward. If I were to stop and right was also blocked, then we're just gonna go down, look left, see if that one's open. So we're favoring right over left, which is kind of good when you're trying to solve a maze, right? Just choose one direction and follow the wall. Okay, and so it's going to go through this loop over and over again to control the motors. And let's try and get these cables happy. So perhaps we find this. So we're looking, running. If that motor ran, I heard it buzz. All right, so
Not going forward.
no, it's one of these cables. It was doing this to me last night.
Oh, cool. Yeah, electrical things.
Yeah.
In the Irish.
There we go.
Ah,
So,
All right, going forward.
going forward,
Now let's give it.
turn right. Turn right.
Oh, that's actually this demo would be really good on the floor.
it would. It would. We need, if I had it hooked up to a battery, we would do that.
Oh, I
Unfortunately, it's plugged into AC right
Oh,
now.
I just got your forum. Oh, there we go. Okay, great.
So you can hear that pause where it turns.
Seems like pretty
Yeah.
Yeah. So we hear it turn.
Oh, no, it's picking up the echo from the cable.
Are you holding that up for connectivity?
Yeah. As soon as I get the cables right, it has the right angle where it's happy.
Yeah,
All right, so-
we saw it turning.
Yeah, so we saw a stop, turn, stop for a second, and then move forward again when these cables work right. So we have a full robot now that can actually interact with its environment. So one of the other things that I'm going to point out now that we've kind of got all of this working is let's talk about how to expand this robot. So this robot, I referenced last time that this was going to be kind of a trial demo, using everybody here as guinea pigs for this. So if we look at here, the robot has this little lip that is on the edge of the top barrel. So zoom in. You can see this top ridge. The idea behind it initially seemed very silly, but the idea is that we can clamp on a sensor anywhere we want around the edge of this. So we could have more than one sensor on here if we want, different types, different styles. It just takes a separate plate. So the 3D print of this model allows for 0 overhangs, and it's a clamping system. You put a bolt that goes down and goes into a nut at the bottom and just hangs onto that edge. So as soon as you tighten it up, it holds it in spot, and you can design different plates to hold different sensor types of this. So
Does this setup have like a name? Because like I've seen that like circle last. It's like the Zumba or something. Like is there like a term for the turtle? Turtle? Or
Plan for the robot. The platforms, the two.
yeah. Is there like a name for that? Because like a it's called
Yeah.
Zumba then.
That is, cylindrical shelf.
Shelf.
Could you 3D print like a clip-on thing, so you don't need the attachment screws?
yeah, you probably could.
I hate screws.
Even use TPU of some kind of flex, like
Yeah.
flexible, so it can like snugly,
I think the problem with TPU is that I don't know it would give you enough tension to hold on to.
Well, they have they have 98 all down to 30 or whatever. They have all of the different levels of hardness.
You can use that PLA snaps.
Yeah,
So
yeah.
Uses a threaded insert.
Without breaking though. That's-
You don't worry about holding the nut.
Yeah.
I made a
Still,
switchblade knife with.
I hate hard stuff.
Yeah, I thought that. But I mean, I would almost, think of either of those.
The point of it is it's supposed to give you an open platform to add whatever you want to it. So whether you design a clip-on piece or whatnot, you can design your own sensors. And if you'll notice, give everybody else a shot of this too. Can't see this table. Here. You'll notice that there's a lot of wires going everywhere when you're starting off with development of something. This is probably what it's going to look like. It's going to have wires all over the place until you figure out what works. And then you can start designing circuits and stuff to minimize a lot of this and start doing some wire management. And one of these days, we'll actually go through and talk about some power management, because there is actually 3 voltages running on this little robot. And we'll discuss why we would do that. Any questions that anybody wants to see more of? Yes.
If you have those in vertical position, they like table legs
Okay.
and doorway.
Okay. Good enough.
Yeah, those solar sensors, they're a little more, the resolution's higher if you put them vertical instead of sideways.
Yeah, that's what I do actually, vertical. Oh,
Do you use a second sensor or is that just there?
It's just there because this one has 90-degree pins already soldered on it, and I pulled this out of the bag. That's not going to work. And then this one has a JST connector on the back of it, and I didn't have my JST crimper, so I won't make a cable for that one.
Are you gonna get feedback with 2 of them? Between the 2?
That's a good question. I don't think so because it's pretty directional.
Yeah. Yeah, usually try to aim them away, but yeah, that can be a problem.
You're doing it synchronously, you're creating and stopping, so that if you do it that way, there'll be no feedback.
Yeah, that's true too.
So Ethan, the Pi Pico is generally a 3.3 volt device, right?
Correct.
And if memory serves, I don't know if they're different now, but aren't the ultrasonic sensors 5 volt devices?
They are.
So was there anything special you had to do to make them talk?
So there's actually 2 buck converters on this because this is actually running at 12 volts because the motor controller down here is set up to run at 12 volts for those motors. So we're pulling 12 volts into this breadboard via these 2 cables right here, which is just plugged into the wall. And then from that, we've got Sorry. I've got this little tiny buck converter. Very tiny. Okay, yes, you got there. Get it. Stop. Okay, how do I turn it back off? I won't stop. Okay, so this little buck converter drops it down to 3.3 volts for the Pico, which is great if you have very few electronics. This little buck converter actually, I think it's like 600 microamps or something like that. It's like just above the Pi Pico and maybe one other device. Like I run a DS player off of the same buck converter, and that'll work. And then back here, I have probably one that people use, and it is a voltage regulator that you can actually set. different
That's the one.
voltages. So,
I think I have that one. It has the little display, and you can change it between.
so I've got 12 volts coming in, and I'm putting it down to 5 volts, and you just by adjusting this little screw, you can drop that voltage down. So that is being used, and this breadboard is horrible, so I'm not using the power bar on it. I'm using on this side.
The big one. Something about their tiny.
I'm using 2 rows for the ground and power in the same way that I've used the power side of it.
Okay, so yeah, so you're driving the ultrasonic at 5 volts,
Yes.
and even at 5 volts, you can trigger ping with 3.3 volts. So the GPIO out will work. Are you voltage dividing the return in to drop the return down to 3.3?
No.
And you're getting away with it?
That may not be safe for the GPIO pin. They may not be tolerant of that for forever.
Yeah. You may burn something out and whatnot, but it does work. I have seen some distance calculation anomalies that probably has to do with extra voltage there that it's not expecting.
I have some level converters.
Yeah, you may want to voltage divide the return out to get it to 2.8 to 3.3.
Yeah.
It's interesting, surprising, and relieving that the Pico is tolerating it the way it is, but
The Pico will actually tolerate
Yeah, some do. Like Expressive, the CEO said, like the ESP8266, he said the inputs are, or the
5 volt
ESP32, they are 5 volt tolerant.
okay. Oh, in that case, you're set.
I don't know about the Pi Pico. So.
Pi Pico is different though, but
Yeah.
Yeah, I mean, you can
the spec.
run servos as well that tend to be 5 volt.
Oh, but yeah, you're just sending a signal out. So yeah, that
Yeah,
3.3
that's just
tolerant, they're just like, it's close
Yeah.
enough.
No,
Yeah.
but when you're having something come into a GPIO pin, you
Right.
want to, because of the impedance and the resistance inside that.
Yeah.
You gotta go by the spec, and I bought a whole pack of level converters for that purpose. It's a tiny little board. I'll give you one. I mean, next time.
Yeah, no, I mean, I've got hundreds of them.
Okay, you do.
I just didn't put it on here. Cause like I said, I did this last night. I got home at like 10 and finished this whole thing.
But yeah, we recommend using level converters. Just
Yes.
So,
Yes.
you know,
In this case, the Pico will tolerate 5 volts.
Oh, amazing. Yeah, just go with that then.
But
what do you mean? It's official or?
yeah, I believe it's officially on their documentation that you can run it, The problem is, with most 5 volt systems, you potentially getting just above 5 volts,
Yeah, 5.1.
right? And so you can't power it off of 5 volts for
This
very
is-
long.
Is it the Pico 2 you're talking about now, or Pico 1?
This one's a Pico 1. This Pico 1 WH.
Or WH? And it says here that says Pico GPIO pins operate at 3.3 and are not 5 tolerant.
The diodes, back to back.
Okay. That'd be great.
You can probably just avoid this, use the Arduino, right? Because everything there is like 5 volts.
Yeah. Our point is not to use the Arduino because there is so many resources out there for the Arduino. There's not the Raspberry Pi Pico. And so building up the resources for Raspberry Pi Pico so people have the option, just introduces it. So
I mean,
Hey. I get a break. Very good.
yeah, I don't not tolerant, you know, the quick AI over. A level shift.
Sorry, everybody.
Too resistant. Yeah. Like, quiet, whatever. It is, yeah, I mean, if you have a red wall, what it is, usually, but I like finding little boards. Well, they're kind of convenient to put into your circuit, so it's like.
I knew to resist cheaper.
No, but the clean, the hard part is where do you put those in unless you have a board you design for. And I don't like to me, breadboards, I like getting those out when I, you know, have something stable. Don't want a breadboard.
Yeah.
These things can really pop out of those quickly, easily. They still have a lot of, well, you know, DuPont was, but.
More than anything, I hate the clutter of the tables.
Yeah, I mean,
So,
yeah, you don't have to. Sometimes things can last for 5 years with the clutter, but it's
Yeah.
hidden and it's out of sight, out of mind.
so any other questions about anything? Okay, cool. That's.
Thank you.
Thank you.
The RP 2040 does have 5-volt tolerance, but doesn't mean the whole package does, I guess. The whole,
Yeah.
Pico itself, you know, there's some other.
I mean, the Pico, our can run off of the USB. It'll buck it down to 3.3 itself. One of these chips does that. Not sure which one.
Yes, there's some,
And it can output 5 volts on that pin right there.
Hmm.
From the USB. So USB through to that pin can output 5 volts.
oh, that's just that might be a
That's just
pass through
yes.
regulator.
Yeah, it's just a.
But not the PI, yeah, it seems like there's a little bit of, yeah, the chip itself can handle it, but the board, something is not recommended for the use of those GPIOs.
And how do you choose between the buck converter and the elevator?
Just what I had.
Is there like advantage one or the other? Like, isn't something like, or am I confusing like something was like DC and another one was like used for DC or something?
These are all DC to DC.
Yeah, these are all DC to DC. This one, so with the buck converter, it's usually dropping down to a known value. With this converter, I can change it. So I could use this one to do the 3.3 as well. Or I could, change it to whatever.
That module, right?
Yes.
And that you had that little.
So this one takes voltages
Yeah.
up to, I want to say 20, 24, 28 volt, and we'll drop it down to 3.3.
It's all fixed, so like there's like a list of different types in different.
Another part of the answer would be regulators lose a lot of energy to heat. For example, if you're dropping 9 volts down to 5 volts, 4 of those volts is waste heat, whereas buck and boost converters are pretty close to 95% efficient.
And they make them very small now. I got even smaller than yours.
What was the first one?
So the regular, really convenient to have.
Oh,
associated.
old fashioned regular.
Yeah.
Linear regular.
Linear, those are, if you have an old computer with regulators, you can feel the heat coming off.
Yeah. Arduinos have a regulator on them, and that's a good example. If you power your Arduino with a 9
With
volt
the 9-volt
battery,
battery.
it gets hot. And you're wasting a lot of energy.
But sometimes regulators are preferred, or is it cheaper?
They're much cheaper.
So it's
It's a
cheaper.
very simple passive component.
Have less ripple, so like a buck would have a little bit of ripple
Yeah.
instead of switching on and off. So like curious, we're worried about RF and stuff, would use a regulator instead of a buck converter.
So it's if you want real smooth signal without having smoothing capacitors and all that.
Well, thank you, Ethan. And can we put you down for next month as well?
Sure.
All right, outstanding.
I figure out what it is now, but.
We're gonna do slam, just timing wheel odometry and a pink sun.
All right.
All right, guys, well, are you doing a show and tell later with the?
I guess, from now on, it's, lunchtime and free.
Access fee, that's serving fee.
All right, so it is 12:33, and, we'll continue with the show and tells. Again, if anybody has show and tells that I have not put on the list, let me know.
Yeah, for,
You?
I'm so sorry.
Go ahead.
So for some of our newer folks, we're a bunch of guys and gals that love building stuff, solving problems, and basking in the glory of solving some problem, right? That's in our DNA. I love hearing what people are working on. So it doesn't matter about your experience level or background. We all just want to hear what everyone's working on. So if you've got any project that you're working on or making progress on, it doesn't even have to work. It doesn't have to be finished. None of our projects are ever finished. They're like kids. Even when they're grown up, they're never finished. So yeah, just please, yeah, don't be afraid. I personally love hearing what people are working on. So if you've got anything, big or small, beginner or advanced, bring it in. Bring in some hardware. If it's software, grab a couple of screenshots or to share, and then just tell us a little bit about it during our show and tell, because that's what makes the meeting for me. I guess I'm being selfish here. Is I love seeing what people are working on. So don't be afraid.
Okay, you add me to the list then?
Sure.
Perfect. What's your name?
I'm Patrick.
Patrick. Brian?
Yeah, I guess so.
Okay. All right. So, to kick it off, Ethan, you're first.
All right. So I brought my Botango Maxwell. And really I want to emphasize the coolness of the software that the developer created. So Maxwell is a product you can buy, the package you can buy off the shelf and put them together and start playing with them. But the software itself can be used for anything that has, servos and Arduinos and stuff in it to animate. So I'm going to start off by showing you kind of an end animation here. I'll just play him and let him run somewhere. Okay, so this is, make sure my volume's up. So Maxwell, if you've ever been to Disneyland and gone to the train, he's one of the parents there. So I started animating, they're kind of interchangeable.
Oh my goodness.
The fun thing about him is this animation, if you've ever used video editing software, and you're kind of familiar with keyframes and just layers of different videos and audios, this software is just that. And then the animation aspect, it uses keyframes. So you tell it where you want the position of all your components to be at a certain time, and it'll interpolate the acceleration, deceleration for a smooth animation between those 2 points. So if I start them up from the beginning.
The answers are getting shorter and shorter. Oh, look at all the people. To Walt Disney's Enchanted Tiki Room. Hey, Michael, yeah, Mabel, pay attention, it's showtime. So Richard.
Okay, so that animation, the first probably 30 seconds of it, I learned how to do in about 10 minutes. So the software is amazing. So let me switch over real quick and I'll show you some of the software behind it and how to do this. So okay, so this is Botango, and when you are animating him, I could put a specific time. Now, this. And so at this time point that you can see right here at about 1 minute and 45 seconds, if I want his head to be in a different position, I literally drag the animation to where I want it to end. And you'll notice it put a little dot right there for his head movement. So between this dot and this dot, so between this dot and this dot, it'll figure out how fast it needs to move to get from that position to this position on its own. So I don't have to do any sort of calculations or anything like that. Now, at that same point, maybe I want his beak. So I can go down to mouth joint, and you'll notice the screen has changed a little bit. Now there's this little arc here, and I can change the position of his mouth. But let's say I want it there. So now I have a dot for his mouth point. So if I come back to his previous spot and I play this, you'll notice his head slowly start moving down. And the online video is very choppy compared to what you see on screen, but it'll slowly move to that position. And then if you find a set of animations, let's say he's talking a lot, really all you care about is up and down for the mouth. You could just highlight a whole bunch of them, copy, paste, and it'll do that whole time frame over. So I find this software really cool.
It's really good, isn't it?
It is.
Botango.
Yeah. Yeah, and I'm sure we could get the designer to come talk to us about
You
it.
do a song, and I'll just record it.
Sure.
What's the name of the software?
Botango.
Botango?
Yeah. BOTANGO.
Yep, I went ahead and
Yeah,
pasted the link in chat.
It's free. That's the cool thing. You don't have to buy the, actual hardware.
So it'll do the interpretation for you, but can you go in there and mess with the NG curves?
I think
Yeah, you can. It's got a curve editor. Jim and I know about curve editors. We had to work on it.
Oh, cool.
Oh, no problem. What's also what's the guy's name? The owner of the company.
I want to say James.
James?
I have to look it up.
I can't remember. But anyway, he gave me the joystick and he said, "Here, be a animator," and then played the music, and I
Yeah, you
did
can
the dials and made the recorded basically the whole performance, made the beat go, and then he said, "Here, you want to see it back?" and played it back right there, and it was like, wow, that's pretty cool.
Yeah, so you can use joystick or controller to.
And yes,
animate.
that's if you have even if you have no skills, you could do something pretty kind of, cool for at least family and friends.
And it really turns animation into anybody can do it very easily. So I find it really cool. And it just runs off of a standard res Arduino. And he has a special board to plug in the servos, but it doesn't require that special board. It just, for his kit, you take wire 19, you plug it into slot 19. You take wire 18 and plug it into slot 18. So it's a very easy, well thought out system.
So how do you, can you import new models into it, or?
Yeah, you can build your own model. So if I come back to let's close this one. Say that. So he has 3 different models from his kits, but you can just create a new project with your own model set. And then I haven't played with this one or this quite as much, but you come in here and you say, you have a stepper or you have a servo motor. So there's my servo. What is the speed of it? A cube. And so you start off very simple and you do like block components for arms and legs and whatever other pieces you need. I don't know yet if there's an import, like if you have a 3D model or something like that, and you want to import it and then put joints on it. But I believe that exists as well.
Oh. Cool, very cool.
That's
And the guy has like, if you go to a show, any maker fair that he's at, usually has a discount off of the $350 retail price. So it's it's a little bit pricey for that, to get the bird and everything.
yeah, it is, but
He like at a show, he'll discount it. If you go to a show and you want one, check it out.
discounts are still pretty pricey.
Oh, yeah.
I think instead of like 350, it's like 300. So
Yeah,
I
that's
mean, you're
still pretty good.
still paying a little bit, but if you have your own, robot or, creature, you could animate it in the exact same way. You plug it in, you turn the servos on through the software and you're good to go. So,
Cool. All right, right on. Thank you.
yeah.
Okay, let's see, next we have.
All right. I think I'll just stand up. So rather than focus on the software, I'll talk about the hardware. So this is the BucketBot 3. If you want. So this is just one in a series of robots that will fit in a bucket for easy transport. And so I just thought I'd show off some of the ones. BucketBot 2 is documented on Instructables. So you can see the previous one, which was done with like hand, machine, aluminum, and all that. So I really like the vertical style of these robots. It has a handle, so all good robots should have a handle so you can grab it when it takes off. And the vertical style, unlike the stacked versions, you never have to take it apart to get access. Everything is available on one side or the other. So I really like that. So handle, really important part of robots. A base. So when you are experimenting with it and you want to run the motors, you want to have it something you can put on. And then the other really useful feature is a switch for the motor power. So having a switch, and I use these lighted switches. So those are the features that make these things really great. On a previous version of this is a Windows based robot, and the previous one had a little tablet PC. They use like WinVNC or whatever to go to a thing. This one, I decided to experiment. There is with an HDMI transmitter. So this monitor, it was like, so so the monitor was like, these are cheap. These are like $40 or $50 on Amazon, but I got an HDMI transmitter and receiver. So this one is not connected to the internet. It's completely separate, and I'm just running a battery to run this thing, but you can plug it in.
That monitor works.
Yeah, and I got a Bluetooth keyboard and mouse, so the whole thing is just wireless with no Wi-Fi. So anyway, so I don't know if it's a good idea.
Oh, it's all Bluetooth.
Yeah, Bluetooth and the HDMI transmitter. So the receiver's on here on the.
So that's like, is that like Bluetooth, like
the HDMI is whatever frequency, I don't even know.
But I mean, the Bluetooth.
And the keyboard and mouse are just standard. Yeah.
The Bluetooth version is a higher version than your old ones, so it can handle that.
Oh, I think the Bluetooth before. Yeah. So but it's just generic keyboard and mouse. So yeah.
Right.
Yeah. So the nice thing is, with no Wi-Fi, it all operates. So I'm not, like I said, I'm not going to get into the software. I've used RoboRound before. It's a Windows app for doing traditional machine vision, and there's a module in there that can identify fiducials. So fiducials are very specific geometric patterns, and when you run this into a fiducial recognizer, it will tell you from the perspective of the robot the X position, the Y position, the Z position, and the rotation in 3 dimensions for this. So from the robot, you know exactly where this is. And so that module cranking out just the X position and then a couple conditionals for the motors, turn left if it's too far to the right, or turn right if it's too far to the left. I did this entire thing. This was partly, I'm a mentor for a FIRST Robotics FRC team, and they put fiducials all over the fields now. So I was telling them, rather than trying to worry about automatic moving around all that, if you could just park in front of the fiducial, then you can just put, if you get close manually and then just say go and center yourself, then they could just say push the button to score. So the demo I'm going to show, assuming it works, it works now.
It worked at all.
Yeah, I know, it worked too much. And then the motors I use are also steppers, open loop steppers. The idea was that if I could sort of get away without having any closed loop stuff, but I think in practice, they're not as precise as you think they were unless you, maybe if you run them slow.
As I discovered, they're strongest when they're holding still.
Yeah, no, I stopped the program so it would replace the battery. Okay, yeah, so the demo is very simple. It's basically just go up to this fiducial and stop. So, but like I said, 2 conditionals and a fiducial module, so.
Buddy,
Right.
Love me more.
I'm still working on the motor control, but yeah. Yeah, that's it, so. Entire demo. It works. Yeah, like I said, it's like a line follower. It's like, you know, it's just like 2 conditionals is all you need. So yeah. Get over it. Anyway, I could do a lot more. Since I know the rotation, the y-axis, I could actually have it so if it's twisted, like if it's over here, I could actually do a curved path because I know the rotation of the fiducial.
oh, you have some feedback that indicates, what is that called, skew or the angle?
So will it search the room?
Yeah. What's that?
Will it search the room?
I haven't done that yet. The previous one I did, so I spent 3 hours, you know, on this so far. So yeah, all of that is possible. So the previous one I did a fiducial course. I had like 4 of these around the room, and it would scan for it, find the next one, go to it, and that's you ask if it's tilted. So if it's tilted, it gives it a hint which way the next one is. So I did that for the previous one.
So in the library or the engine to detect the fiducials, are you getting feedback about distance, rotation?
Yeah, it gives you all those variables back. Yeah, very simple. Yeah.
What camera?
Oh, this is just a USB camera. The main feature of this one, I think it's a Logitech, but it has the 1/4-20 mount on the bottom, so it was easy to mount to the servo.
But how do you do distance then?
Oh, the fiducial module just tells you how far away it is. Yeah.
Oh, and so it's doing it by perspective analysis of the.
Yeah, it's doing all the geometry. Yeah.
Geometry.
Yeah, the fiducial is like this is in every vision app is the fiducial software, and it tells you from the perspective of the robot the X, Y, and Z distance and rotation.
Because that thing is a known
Does it have to be printed at a specific, size?
No, it'll work. It depends on how good the cameras and all that. It'll work really far away.
The answer is yes.
Yes, it has to be printed. 1 inch have to be 1 inch. Those
Yeah,
squares,
that's right.
right?
Otherwise, the
No,
distance would come out different.
No, if you put in the camera, like for this app, I haven't done it, but if you put in the aperture and all that, you can calibrate it. So
Calibrate.
So it doesn't matter what size it is as long as you calibrate it. So, and what I'm doing, instead of like going in and setting all that, I'm just observing the number and I'm just using, oh, there's my constant. So
Okay.
yeah, so I just sort of held this. Okay, I want to go this far. Oh, it's a 9. Okay, so if it's less than 9, stop. Yeah, so that's one of my 2 conditionals. Yeah, yes. Yeah, so very simple stuff.
Oh, that's easy then.
Any questions? I don't think there's, I'll turn it off and pass it around. And this one, so I decided, you know, I try to keep the machining as simple as possible. And this one I use T-slot because it's widely available now. Some of the brackets are the metal T-slot brackets for the servos and the vertical piece. And then I decided to 3D print the rest. So you can buy perforated plastic and all that, but most of the corner brackets are there just because I printed them round over because the T-slot is kind of sharp. So the 3D printed brackets are largely just to make them smooth so you don't scratch yourself. So.
Thank you.
Yeah.
Cool.
Thank you, Carl. Nice. That's good. Thank you.
Yeah, you're up.
All right, let's see. So I brought in Big Orange after here's sharing video right here. So Big Orange, I kind of had planned some upgrades to it last year, and I brought it to the Robo Games last year, and then kind of put it aside for a while and looked on my other project with the Parkosaurus. But I came back to Big Orange, and first of all, printed a brand new tray out of PETG because the last one. So this robot's been through a few ticks of time and the and sunlight, and the PLA tray, got all warped and the space between the different parts kind of widened. And anyway, so this time it's PETG, which is more, it's known to be, much more tolerant of sunlight. So the other big thing was the motherboard is a Latte Panda running Windows. So here's the old one. And you can pass it around. These are really quite good. If you need Windows or Linux, they're good, a little expensive on the expensive side, $200, I think, for the Linux, and then another $50 for your Windows license. But they, this is the what's called Latte Panda Delta, and the one I bought is the 3 Delta. So it has double the CPU and 3 times the GPU. And these have a built-in Arduino Leonardo. So there's a full set of GPIO. So it's a coprocessor, Arduino coprocessor on board. And you could just plug things directly in that and upload the code with Arduino IDE or what other, IDE to COM4. And it's like a built-in Arduino. And so I use that for servos and sensors and whatnot. So upgrading the motherboard takes a lot of work because that's where all the software is and everything ever and all the configuration. So it took some time, and I wrote up a new install bat file with all the different steps, and all the code is on GitHub, but I had to, I sort of found all this disorganization that I did and tried to clean it up so that with submodules, the GitHub, like Big Orange, but then with submodules of all of these dependency Python modules that I needed to change the source code. And so then it's a very convenient way to have this hierarchy of your main code and then these submodules that you might have forked from somewhere or whatnot that you needed to change, that you can't just install and use with pip install is the way. So the other thing I did was I worked on the battery. I was tired of I had some issues with the I wanted to measure the battery, the main battery, and here you can pass around some of my equations and stuff that to measure the battery. As the battery discharges, I wanted to get a percentage out of how the battery of the state of charge. It's a different SOC, but state of charge of the battery, like how many percent. And there's a little indicator on the battery itself down low, like 4 LEDs. But I wanted it digitally so I could track and then make the robot go back to his charge station and all that. And my previous logic was, I've been fighting with it for a long time, but basically it's just a voltage divider. Bring in 12 volts, go through a resistor, drop it down to like 1 volt to 2 volt, and then that can be read by a 3.3 volt ADC, analog to digital converter on board of the Arduino. And then you need to convert that to a percentage full. And so you have to figure out a kind of a curve. I just did it the old-fashioned way by watching those lights as the thing discharged and then recorded the voltage. So, but it's like there's a lot of complexity to this one little thing you can deep dive into, because like voltage goes up and down based on if the motors are moving and all that. And so, but you want your, on your phone, everybody's used to this number that monotonically goes down, 93, 92, 91. Whereas in real life, voltages are going up and down. Unless you have a better way of determining the state of charge than voltage, which I don't in this case, then you have to come up with this curve, and then some logic in your function that smooths it basically, and that sort of thing. So so that was an interesting thing. Then I added another battery because the SlamTech, the SlamTech module is the full LiDAR system, and that's for the navigation. You can kind of see it here. This is the LiDAR here. And, so I added a 12 volt, basically Dr. Bruce stole an idea from him again. I bought this 12 volt, auxiliary battery that I've now mounted here to supply power to the SlamTech board and LiDAR. So now that does not draw from the main battery. So that helps, give you a little bit longer time of run time. And so that, and then, yeah, just, it's an exercise in cleaning up there's nothing better to clean up your code than to have to reinstall everything on a brand new motherboard. And this, you're talking like a Windows system here or a Linux system where it's not just an Arduino one piece of code. It's like lots of stuff going on that system, and getting the drivers working, lots of nuances. And so I have to check that code in now. It's like there's a lot of changes. The other thing I've been working on is getting vision chat GPT or visual LLM support. Right now it's just using AI, OpenAI. So, or they call it vision model, right? Or
Vision or multimodal.
VM or VLM. Yeah. So I'll try to demonstrate that now. What I've also done is I finally decided, okay, I'm just gonna, I have this big if else for all the commands of the robot. So, hey, orange, what time is it? So voice activated, and it's got a trigger word. Let me turn up the, sorry, let me have the volume down. Hey, orange, what time is it?
It is Saturday, May 10th at 1:00 p.m. It's afternoon.
Hey, orange, status.
This is my current status. I'm currently closest to the unknown. The battery is at 27%, and I'm feeling happy.
The emotions are kind of like always happy for now, but that may change. So then you can also say things like, you can actually, so I have this long list of commands that you have to say in a very exact way for the parser to catch them, because I'm just doing if this string is in the words that are heard. But then at the bottom of that now, I'm sending it to ChatGPT along with a prompt. So, hey, orange, what makes you tick? Hopefully it's next to you.
I run on a Latte Panda computer and an STM32 controller, using a combination of Python and C++ for my programming.
So I didn't write that. That's from my prompt describing the everything on board, or as much as I could, sending it to ChatGPT and along with your question, and then that's its response. So this way you can do intelligent things. Now let's see. I experimented with the vision capability of ChatGPT, and it said, I will not describe any persons or what they are doing. And I'm like, it's time to get a local one pretty soon, because I'm not trying to be malicious. I just wanted to say, oh, you're lifting a computer or something, But so let's see what it says. It won't say anything about people specifically, but it will say things about what it sees. Hey, orange, what do you see?
I see a group of people sitting in a classroom or meeting room. There are tables, chairs, some maps, or posters on the wall, and various objects on the tables like a water bottle.
It's awesome. Oh, it's a little bit too low to see Cal State, but was gonna say, do you know where we are? Let's see. If I point it this way.
It has GPS, right?
No, I'm going by the vision only, I'm saying. Would it know from Go Beach? I don't know. Should, might?
Ask him to describe what's on the maps.
No.
Please ask me to save map names.
Hit a button. That, I have these 4 buttons to do common tasks that are hooked up to the Arduino. So if I wanted to stop immediately, I can just push it.
Canceling current action.
You know, so if I grab the robot, hit that. Also, I have on the I have a joystick. You can hit a kill switch too. So yeah, well, if it was a little, it's too bad if I tilt up, see if it says. Oh, I don't know if you can read that.
Yeah, I don't think it can resolve it.
Hey, Orange, where do you think this classroom is? Oh, it's not going.
The classroom appears to be at California State University, Long Beach.
The unstructured demo, I didn't hear that. Did anybody want to see that this,
You went around.
went around? Yeah, so these are, you know, the reason I run Windows is for historical reasons, because this whole Slam Text system, for those not familiar with it, Dr. Bruce, who was one of our, you know, our longest members and educators here for years, he got a group of us into this $500 mini robot that we took apart, and it was basically a reference design robot with a full support for you know, converting to your own robot, so you could reconfigure it in this all the dimensions and take off the wheels and motors and whatever. It came with this little kit, and the main thing to keep was the LiDAR and the SLAM, the simultaneous location and mapping. So this whole system was, you know, its main interface was through Windows, and that's why we ended up doing a whole Windows system. And you know, pretty much every product is all in Python these days anyway, and so as long as it's, you know, Windows and Python, you can put in a mini Conda environment, and as long as you have the wheels, that everything will work in Windows. Almost every project has like how to install in Windows, how to install in Linux. So it's pretty much, you could do that, but my other projects are in Linux and ROS too. So this is sort of the older one, and I had to revisit all this stuff in Windows and getting that to work, but everything you can imagine does work under Windows pretty well. Except, yeah, you know, things like large language models, well, I'd need a code processor for that anyway, but, so yeah, I guess, yeah, anyone want to ask it something, or, you know, I guess that's.
Well, quick question.
Any questions?
Are you parsing the text output or the text response so that you can actually do things like move the claw or move the.
Oh, not yet. In fact, I just had the first idea is to, like, if you say a command wrong, I'm sending the whole list of actual commands and ask the robot to, or ask the ChatGPT to correct the person. I wanted to show you, let's see if that worked. Like, there's a command to it to open your eyes, close your eyes. Or I'll do open so you can. Hey, Orange, open your eyes. So this is an animated eyes to make the robot, you know, this is how I normally would show the robot in public. Is it, well, it's supposed to be the whole screen. Like that, oops, that. So, you know, these are the eyes, and then there's a control panel here that you can do various things. So if I close your eyes, also, if you notice, I'm using what's called the Mycroft Precise Wake Word system, which is it's a lightweight neural network model that is old. It's a recurrent neural network that I trained to recognize, hey, orange. And you notice those lights come on if I say that. But otherwise, it's taking up like 15%, 20% of the CPU, or it varies, maybe 12% of the CPU. to just listen for that one thing, but everything else people are saying is not recorded. So the other way I used to do it was with the BOSC, with just the standard speech to text, and then look for the word. Then it's translating everything everyone says, transcribing everything that's heard, and that takes more CPU power, and it's a privacy concern. Yeah. But I had to spend a lot of time training this thing with 400 times recording my voice, and I tried to get other people, but it's hard to get people to do that. So if you ever want to help me, just record your voice, say, "Hey, Orange," and then mail it to me.
Use your voices, you had hundreds, right?
I have 906.
Yeah.
Yeah, and this was before, like, I used some generators and did like some famous people, but I didn't do much effort, at that time.
So
So,
I'll run a script and I'll send you a zip file.
yeah. So, but, so that's that system. Unfortunately, my training doesn't work for everybody because training mostly on my voice. But, my wife's voice seems to work.
Jim, you got a couple of questions?
Yeah, well, okay, go ahead.
So you were saying that it can detect voice commands, and if you get it wrong, you can try and use ChatGPT to try and correct.
Yeah, let's see if that works. I'll say, instead of open your eyes, I'll say, show me your eyes. See I don't know if it's gonna work, but hey, Orange, show me your eyes. Oh, I'm sorry, that's the wrong one.
I can't show you my eyes here, but when I'm in action, my screen displays animated eyes.
I meant to say close your eyes. All right, close your eyes is the real command. But I'm gonna say shut your eyes. Hey, Orange, shut your eyes.
I can't actually change my eyes here, but I can close my eyes in a physical setting when commanded.
All right, yeah, well, he gave the term. So I don't know if my prompt is right. I just did this last night, but I'm saying, like, I'm trying to put in the prompt all the commands it takes, and then saying if the user says something similar to one of these, then tell him that he got it wrong. He needs to say this. So, but that prompt needs some massaging.
So I was thinking,
Yeah, well, this is a learning example, not a. Yeah, go ahead.
Rather than using ChatGPT, you probably use an embeddings model, which can run locally really fast now, and it would probably be cheaper, more accurate.
Yeah. I mean, it can run embeddings. Can run on a CPU pretty, or with a Intel GPU, integrated GPU.
I
Probably.
mean, I can run embeddings like instantly on old low-end hardware on the CPU, so.
But with the embedding, right, then I could measure the Euclidean distance. Like if you say shut your eyes, and it's really supposed to be close your eyes, the embedding for my real command, close your eyes, is going to be fairly close to shut your eyes, distance-wise, right? And then, yeah, so my next step, instead of this just hack I just tried to do last night, is to do something like that, where I want to, if the command isn't recognized, it should find the closest one and then say, I think you meant this, and then do it. And maybe the embeddings model would be a way, and not even use ChatGPT. Or ChatGPT, you could use functions, right? That's another option I was thinking of, is, or actually to like convert a command to the closest real command. Yeah, function, right?
Too near and dear to my heart.
Yeah, what did you?
Because close needs to be semantically and in meaning, not just by the number of characters that match. Maybe we can doctor in the break.
Oh, so semantic meaning is a little harder, you're saying?
Yeah, and that's where I'm really curious if embedding will
So you're saying if I say close your eye, if I say shut your eyes, and then I have a function that's supposed to react when anything about closing or shutting your eyes occurred, and
it would be worth a shot. Yeah, but it'd be worth a shot.
But you could run a full 2D model locally or something, right?
Yeah, plus Microsoft BitNet is like.
So these two models, the Quinn models, the small Quinn models.
Yeah, the Quinn.
They're pretty good, and they could probably do this use case pretty well.
Including the embedding thing, or just you're talking about
the whole thing, the whole selection,
Microsoft.
the conversation, the whole thing.
You run your whole thing on device like I'm trying.
Yeah, that's what I wanna do, but, I guess the key thing I wanna do next is, yeah, instead of having these canned, I want the right command to get executed no matter how the person says
That's
it.
called tools, right? So
That's a
you
tool, yeah.
provide a set of tools,
That's the
and you
fun.
say, hey, you got a bunch of tools. Here's what the user asked for, and then it would say, oh yeah, call it tool now. And it'll.
Yeah, that's
That's
when I
that.
said function, I meant
Yeah,
tools.
it could be that. So if you have a tool that says,
Functions aren't the same.
run this tool for anything that involves closing your eyes, then you're not looking for an exact set of words anymore. It's
Yeah.
looking for the meaning, and then it's like, oh, he talked about closing eyes, I'll run this tool.
Yeah,
Yeah.
no, I said function, but function and
They're the
tools are
same, similar.
the same. Okay, it is the same. So that's what I meant is,
Okay.
so thank you for correcting. Any other questions or?
Oh, man, any longer, it'll be a talk. We're good.
Thank
No,
you.
And everything worked, like, it's so much faster and it's working so much more reliably than when we caught up 2 months ago, so.
Oh,
That
at
was
the,
So that board, something.
well, 1 month ago, you mean at the show.
Whatever refactor you did.
At the show, it was so loud, you know, it's so
Yeah.
hard to do anything.
Yeah.
Well, thank you, Jim.
Perfect, thank you.
I'll add one quick thing. So Jim's using the same batteries that I did in mine. They're these talent cell batteries. They provide 12 volts and 5 volts. So they're great for these robots. Yeah.
What kind of that?
It's a lithium ion battery. So he's got a little one and a big one, and I got a medium one, you know, so yeah. And
Talent cell, they're
super convenient for robots.
Yeah, they're full retail, quality, packaged battery with built-in BMS and charger comes with it. A slow charger, in fact, to preserve the battery life. So it does take several hours to charge, but they're, you know, I designed mine, you know, so it even has the, a charging like connector in the back, but I just packed a vacuum charger and used the charger that came with the battery, so it's nothing unsafe.
Here, I'll paste an example of one of their line in chat, so that captured on record when posted.
Okay, up next, Seth.
Can I share my screen?
Yeah.
Okay, so. It's a little better. Okay, so this is something I've been working on for about a week now. And it's using,
Can you increase the font, like, Control plus?
so I've been working on using the new Quen 3 model along with a bunch of tools to be able to say, like, give it a task I want it to do, and it can step by step perform that task. So I got it to a point that I think it's kind of reliable now. So I can say, like, for example, set my desktop to light and red. You can see currently I'm in dark blue theme. And in real time it should. Might take a moment because I don't have the model loaded yet.
Hey!
Set to light red, as well as it can read and write files. It can modify my wallpaper, download stuff. So I could give it.
Look at all of its logic there.
Yeah, I could give it a more advanced task, like
Oh, it's recent.
set my wallpaper to a photo of Super Mario. And if it works like it did before, it should go online and search for a photo of Mario and try and download it and set it as my wallpaper, which will take at least 3 commands for it.
Is that through a tool as well? You have a tool?
So yeah, I'm using LangChain,
Oh, LangChain.
so I can just give it a bunch of tools I wrote in other.
That's way ahead.
And tool-enabled models also, excuse me, the models you use should be tool-enabled.
Yeah, definitely, like the Quen.
Mhm.
Yeah, he's way ahead of the picture. I want to do.
He's ahead of me, actually. That's my job.
How is that? Oh, wow, the future's gonna be weird.
Yeah.
There's campers so much.
Oh. And it's going 13-year-olds number the country.
When we were 13, our parents all had Linky 12 on their VCR.
That's true.
Just technology moves.
This one, I wish.
Yeah, but now we're on the receiving end. Doesn't feel right.
That's right.
Well, fine.
Remember how dumb your parents were with the technology?
Yeah. Here it comes.
Yeah.
Lots of other.
Yeah, someone at work once said like 20 or 15 years ago, like what technology they come up that we don't get?
Yeah.
Because we're all in technology.
Mhm.
Well,
Might
it's
be,
a matter
it
of
might
like-
be some of the,
Partly it's the amount of playtime you have as an adult,
Yep,
which is
yep.
lower.
Right.
Again, it seemed to just crash, you know, we're just sat there loading shit while.
So what you're saying is you've given AI access to your computer.
Yeah, pretty much. I believe
Oh,
I
did you find Mario?
Yeah.
Since you put it that way.
Turn the mic off right now.
Even can run man, but I don't usually have it do that much. Oh, it just downloaded.
Did it download?
It's downloading.
See if it'll. Oh, my wallpaper.
Jim was demoing Orange for a Homebrew Robotics Club meeting online, and then he started talking about it, and it started responding to him. And it was classic. It was like, stop.
Yeah, I know.
Months ago. Yeah. It was so funny.
Oh, I forget what happened.
It started responding to you.
Okay,
We were just
so
talking
this
about
time-
Orange, and it started.
Oh, yeah.
Yeah.
Well, now with the language model. hooked
It
up,
downloaded
it
the
looked
file, but
proposed.
somehow
Oh,
failed
it
to
worked.
set the wallpaper. So that's a little strange.
That's where my
I-
guy.
Yeah, I do know I changed how the whole thing works, so it's a little weird.
So do you have to program each of the steps and then it like chains them together, or does it actually come with those things coded in?
I actually have to program each tool it can use. So like this is my file for internet stuff. Full screen. And then I also have a search function, but it's not the best right now.
So a tool is something that the AI can use. So what tools have you given your AI?
I've given it a bunch of stuff for files, reading, writing, and searching. I've given it stuff for my desktop so it can change how things look. Internet abilities and Linux stuff.
It's changing your wallpaper, the tool you gave it.
Yeah.
Knowing about wallpaper.
Cool.
Wasn't what you came up with.
I'm working on the other thing. It might work, might not. Where I can plug my Roomba into it and it can control the Roomba vacuum. It can drive it around.
Oh, cool. That's outside, right?
Yeah.
Oh, okay.
Should I go get it?
Is there a tool for, you can make.
Maybe no.
Can you turn it on from right now, from where you are?
Not from here. It has to be plugged in right
Oh,
now.
okay.
Does the Roomba have it has a Python interface that you can use?
I have a Arduino plugged into it and I
okay.
communicate via serial.
So you're using AI for this is an agent, right? So you're using AI. What model are you using? Are you using OpenAI?
I'm using Quen 3 because it's like the latest and greatest, and I wanted to see what I can do with a model running on my laptop. 'Cause that stuff it fascinates me a lot.
Yeah. Can you tell me a little bit about the Quen 3 model that you settled on?
Okay, so for most stuff, I usually use 4 billion unless that just doesn't work for some reason. Then I use 8. But it's really neat because they're very effective since they use reasoning. It's like even the 0.6 billion parameter model for a good amount of stuff works just fine. Like you can do like multiplication with decimals and everything and get things right.
So what size model are you using? Have you settled on for this project?
For this project, for now, I use 4 billion because it's fast and also works pretty well.
Okay, so yeah, there's a 1.7 and then a 4, right? So the 4 was working better for you?
Yeah.
Okay.
I know I had a version of the search tool that summarizes it using the 1.7 billion, but doesn't work that great right now, so.
All right, so this is an agent that's using an AI that's running locally on your laptop in real time. And is allowed and has the ability and has the know-how to make changes to your computer. Including writing files, reading files.
Going to the internet.
It's scary and
Just
awesome.
to do anything on the internet.
I've loved it trying to do this for a while, and, you know, with the old ways.
Is this like something you could say, open such and such file in such and such folder and read it to me, like a Word document or something?
Yeah,
That's cool.
I can tell it like, take this file and summarize it and write it as a markdown file. And it'll go and do that. I'm testing this.
So it'll take a file, read it, and summarize
Wait,
it to another file.
You already had to make a tool for that though, right? Or is it combination?
I give it like really low level tools, like write file with this name, and then if I say make a markdown file, it'll just name it .md and write markdown inside of it.
Oh, so it's just, it'll save out as a markdown from whatever, but it's like opens in Word and then saves out as markdown?
Well, it opens whatever format the file is. Like, I don't think it's Word.
Or I mean, if you open it, how do you have to have something that understands how to write out markdown.
Yeah, well, the AI just has a bunch of that ability built in.
Oh, I'm sorry, that's built in. Right, that's in the model itself. So you
This
just,
is a neat test that it's really good at. Where I tell it, find the file name problem. I don't give it the file extension. And then solve the problem inside it.
Wow.
oh, all right.
I did a second ago, and it was able to read the
Files
file.
of file labeled homework. And do the homework inside it.
This is like auto GPT or whatever, right? Everybody's easier.
Someone do the math, grab a calculator. Is that right? Because if that's right, then I need it more impressed.
What's the? We've checked, I don't know about this, we've checked it. Like 3-digit multiplication, even square roots, it's getting correct.
And this is all done in LLM. This isn't using a multiplication math tool.
Yeah, there's no
Yeah,
calculator.
it's getting a lot better.
Yeah, that looks correct.
Wow.
But if I can.
But there's a math module. I mean,
No,
Oh,
this
there's
is
no
a
math
problem.
module.
This is reasoning over the math problem. and
Yeah,
over the
so you
course of
find that
reasoning.
Quinn 4B does a good job at math.
Yeah, I know I think there was a chart they released showing it was like on par with like OpenAI's GPT 4.0,
Yeah. Wow.
with just 4 billion parameters, so. Yeah.
Yeah.
Is Quinn from
Jerry, you press the
Chinese word?
Thank you.
That's it. Thank you.
It's gonna be hard to follow Seth. If you get a 3D printer, you gotta try to figure out what to do with it and stuff, and so started printing, and like, okay, print in place is neat, so if you're not familiar, print in place, where you can have things that like move and stuff that are printed without assembly and still do that. Then I came up with tracks, and so I made this here. And then I hooked it up to Ross with a ESP32, and I can kind of, if I can turn this on, I'll share my screen. Wow, that's like the hell of a world. Or share my screen.
I never got really, I really shared like for years.
There's a billion. I think.
Yeah, you're right.
Okay, so it's off right now, and this is Foxglove. So it's talking with Ross too. So if everything works, I should be able to turn this on first. I should be able to turn this on. It'll find my network, and it'll find Ross.
I'm still freaking out because your desktop could be a floor bot with one wrong move. You just
You know what? I tried. Okay, so this is like iteration 15 of this. So if it breaks, I turn it into.
The first 14
And-
started on a tabletop.
Yeah.
That's right.
Phase 4 table.
I can catch it.
I've got, well, while we wait for this, and hopefully this comes up, and if it doesn't, then, you know, it's network stuff. A lot of these threads were coming off and binding and stuff was breaking. And so like, here's the iterative process. So here's like an old version, and you know, it bends a lot this way. I'm like, okay, so I put a bigger, you know, thing in here. So like 12 hours later, I've got more firm tracks and it falls off less. So there we go. Now we're up here. So what you're seeing up on the screen, I've got 3. On the top chart, I've got 3 ultrasonic, or no, time of flight sensors. And so that's the distance away from my hand you're seeing there. The middle one is speed. So I've got the left speed. When I'm moving, you can see the speed moving, and the right speed. And then at the bottom, just like Jim, I want to look at my battery, and I've done everything that you just described.
I have to talk to you.
Let me see. And then I've got it hooked to this. Now I've got this in like baby mode right now. So I've got a little thing here I can turn to make it go kind of. It'll go a lot faster than things that hurt the legs and stuff like that.
Perfect.
So hey guys, we get a volunteer. I've got a switch here where I can turn on avoidance mode. So if I like try to aim for the wall, it should. There we go. It avoids the wall. Just for fun, I'll go faster.
Oh, nice.
So, sure. It should be able to go, turn off the obstacle avoidance,
Yeah.
and then see if I can go over this mess here.
Oh.
So the idea is it's got a GPS inside, it's got these sensors, it's got, you know, the full program stack inside of it, that I could use it for something like RoboMagellan. Right now, we can go through most obstacles in my neighbor's yards. So like the meters and stuff like that. Yeah, it's okay.
Tall grass.
Yeah. Tall grass, and so next iteration, maybe a little bigger wheels and blah, blah, blah. But to me, this part here is the neat part, because if you're working on a robot, how's it doing? What's going on? So I'm logging over here. You see my logs. You see this stuff in real time. I can see the velocities. When I'm debugging my compass, I can see the heading here. So this is kind of a really cool setup. ESP32, like $4 for everything, you know, so you can use the cheap hardware and still get your network connectivity, and with micro ROSB going back and forth.
What do you have on, what's the main, you have a CPU? You have
ESP32.
That's
So it's
the
like a
controller.
$4 ESP32 mini C3, or I forget the exact model number.
But it's Wi-Fi, right?
Wi-Fi and Bluetooth.
Oh, so
yeah.
from the ESP, it goes to your laptop?
Yeah, so what's going on is
You have ROS running.
over here, I've actually got these 2 panels here running 2 different daemons. One is the micro ROS daemon. So the robot is talking to micro ROS. And then to make Foxglove work, I've got the Foxglove bridge running. And that enables all this stuff. And, you know, and with Alan, I've been talking about, like, it's pretty robust. I can turn it off and back on. I can turn this off and back on, and everything kind of like recovers state, which is what you want, you know, because, yeah.
Right, so this is a good example of no CPU aboard, just a microcontroller and with Wi-Fi capability, and so micro ROS communicate over the network, over wireless.
Yeah. And I feel like I've got plenty of processing to spare.
Wow.
So, yeah, you saw this stuff. And it's, you know, reading the wheel encoders at some ungodly frequency, and it's, this thing is talking through a receiver that's talking ELRS or SBUS, or the exact protocol it's using there, at some 500 hertz. So a lot of stuff going on in that little space.
What was the base model? Did you build this from scratch, or what was the?
Yeah. So that was the whole point. So I got a 3D printer. I'm like, what am I going to build? Okay. Oh, tracks would be cool. So let me try to design us some tracks. So I design some tracks. I just design a chassis. I throw some hardware inside of it, how does that work out? Iterate over it because it wasn't quite right. Like, I think I remember telling Alan, I couldn't run over cord because I had smooth tracks. So I tried with different kind of patterns, and then look at these, but I ended up looking at like the M1 tanks. They just use a flat bar on the bottom, just a very, very basic, super powerful. It goes over everything now. I tried it with and without the rubberized. So here's the pasta dip. It's kind of messy and it didn't really add too much. But
And you can use tracked vehicles in the rubber gel.
yeah, there's the limitations there are like size,
Okay.
and it has to have a kill switch. Not too much else, right? Like the dead man switch, the size.
And you can't use RTK.
Oh, no, RTK.
You can't be caught using
Yeah. And so, and speaking of that, my current challenge, inside of here, there's a GPS.
Yeah, I did.
And it's not working very well. And first I thought I was like setting the wrong parameters, something like that. Now I think it's too close to the ESP32 because the Wi-Fi is like right on top of the GPS.
Yeah, you're getting interference, you're getting RF.
different bands though, right? Different bands though, right?
Yeah, but energy close by, I don't know.
It could be some RF interference.
Yeah.
Okay. Wait, so did you hook that GPS goes right into the ESP? Or
Yeah, so ESP has, I think, 2 UARTs available.
2 UARTs?
Yeah, and so it's using one of the UARTs. And then a bunch of this other stuff. Actually, if I can take a little more time. Interestingly, these are time of flight since there's only one location, right? And it's using I²C.
Oh.
And if anyone knows I²C, you get one address per device. And these are at like D7 or whatever. I don't know what the address is, but so they're all 3 at the same address. Now there is something that lets you change the address, but when you power it back on, it goes back to the default address. So like, what the hell? And so what I finally came up with is I tied the power input of each of these to a GPIO. I turn the first one on. I say, oh, here's your address. Turn the second one on. Now he's defaulted to the base address. But here's your address. Turn the third one on. So every time I flip that switch, I cycle through those. So that's another like micro problem that I had to solve.
I like it.
We're using the GPIO to power it. And then they don't.
It works.
It doesn't pull too much current from the.
You get like, I don't know, 40 milliamps or something. And these things are low power.
They don't.
It's like an LED or something, right? LEDs you can power with your GPIO.
Yeah.
So, Brian, if you tell us the model number of that time of flight sensor.
Not five, I can't. But I can say it. I can go look at it.
Okay, yeah, just curious.
Yeah, maybe you could share the bill of materials, like how you eventually.
Yeah, I should probably build one of those and like the.
Just a quick list is all I mean, really.
Yeah,
Out of curiosity, which 3D printer did you get?
it's the Bamboo X1C, and I absolutely love it. It's like everything fits perfectly.
Plug and play.
Yeah, it's pretty. Let me show you. Here. So here's my tracks. So here's the tracks I designed. Alan, thank you, Alan. Turned me on to Onshape.
We had one quick talk and then like, started overnight. My goodness, look at that.
Yeah, so just like it is, I printed on my print bed.
Yeah.
And it comes off and like this, right? So it's and here's, you can pass these around. These are my test prints. I was trying different clearances between the pin and the shaft that it goes through. And I tried to write with pen what the clearance was, but the pen bleeds on the 3D prints. But like there's, but I was just trying to get it to flex left and flex less in the lateral kind of direction. And so this one hasn't broke and hasn't fallen off since 3 days.
They snap together. That's all the way through.
Yeah, no. So if this breaks, I have to throw it away because I can't.
It was printed like
Yeah.
Yeah.
Yeah, see what you see right there? That's exactly how it comes off the center. We're just like that, all connected, and I can't disconnect it, I can't modify it. But then again, I don't have to.
Like jiggle it.
You know what, depending on the clearance, I've had it like that, and when it is stiff, I tend to break the pins. But, lately, I think it's coming out just like this, maybe one's a little, but it's comes out pretty, and by printing it in a perfect circle, that helps, like,
Yeah.
and that's all calculated, I didn't arrange that, calculated from the software.
You
Oh,
can
you did the
easily make
software.
these pinless. And so you can just
Oh,
snap
snap,
each
yeah,
section together and make
Yeah.
it so much easier. I went through this exact same.
Did you?
thing.
I'm currently happy, I mean, like, things like, how do you tension them, how do you make it bigger and stuff like that, but this tension is okay.
Now, when
it-
you flip that, I mean, you printed that size and then when you have to get it on the wheel, doesn't it, you have to pull a little bit?
No, I take the wheel off, and then I put it on the wheel, then I put the wheel on.
Okay,
So
so it's, yeah, it's done
Yeah.
now.
And bearings. My first try with bearings, and those were helping, and this shaft was thinner, I think no, I broke something else there, but I had to use bigger bearings for bigger shaft holes, so they break less. But again, look, this isn't broken.
Oh, the bearings help the smoothness, is that?
Yeah, there's a little wobbly, a little shaky, and so these bearings, this wheel doesn't flex at all that way now. They got a bearing inside, bearing outside, so they got a nice firm platform for it.
I see.
Yeah.
You got a question behind it, right?
I do.
Yeah.
You say bearings, is one wheel per side powered or both wheels?
Yeah, good question. So this front wheel has a motor.
Yes.
I can give you I think I can show it to you here, maybe. I don't know if it's somebody one of those things. It's slow here because of. I'm not very good at this mouse. Anyway, so you see that front side has that
Yes.
hex connector.
Yes.
There's a motor on the other side of that, going straight from the motor shaft into this wheel.
Yes.
And this wheel slides over that hex connector. This other one, you see the shaft.
Yeah.
I just press and click this wheel onto it. So
Not powered.
not powered. So back's not powered, front's powered.
Gotcha. Thank you.
Okay. That's it.
Thank you, Brian.
You're gonna show your little cube thing, Brian?
Oh, okay.
Alan,
For 3D printing.
No, flex it here.
So I put, yeah, flexing. You can roll the dice like that, and then you can see the numbers and the dice don't fly everywhere. Yeah, I'll see you pass it. But this is a 3D printing challenge because first off, you can't print flat surfaces like that. And second, you have to get the dice inside, so.
Oh, you print halfway and then put the dice in.
And then also I have to print it at an angle like this, so I have no flat tops to worry about.
Oh, wait, what you're saying, you had to
I
print.
print it just like this with just tiny little supports right at the spine, like this.
Tree supports, right?
Huh? Tree supports. And then I print it up to here, drop the dice in, hit go again, and.
Oh, because if you did it on a flat, you'd have to
If you
clean
did it on
out.
the flat, you can have these big spans here,
Yeah, you have.
and it won't be able to span that distance.
Well, and it's gonna alter, like, mess up with the
Yeah, it-
drawing.
Well, you could have the support, but then the
Oh,
support,
yeah.
digging out the support is
Big
terrible.
support out of here.
Terrible.
Oh. You'd have to have the
Doing it on
washaway
the corner
support.
better.
Huh?
Doing it on the corner.
Yeah, of course, the right way to do it, right?
Yes.
Yeah, that's really
Yeah,
good.
well, yeah.
That's really the right way.
Yeah, thanks. Okay, now I'm done.
I think it's cool.
Thank you.
All right, Alan, you're up next.
It pops up on the top. People read.
All right, I'll be back up here so you can hear him a little better.
Draft files. People can
Oh,
custom.
so you did that one from.
Where did
Yeah,
it
your own
here?
scratch.
And,
So how
uh,
does it
go ahead. Did that here. Trees. Here's a go.
This is a really, yeah, that's a nice, it's nice. Like a message in the bottle, or it's ship in the bottle. Actually, I wanna see that. You're gonna, next challenge with the 3D print the ship in a bottle. The bottle has to be clear.
Yeah, so for the things that I wanted to do for the bot, I've got a pretty powerful SBC as far as SBCs are concerned, a little bit faster than Raspberry Pi 5. So I was trying to figure out all the things that I wanted to run on it. So, and along with the 600 million, not 600 million, 600 million parameter Win3 model that supports full use, that I can run on device and get like between 16 and 19 tokens per second. Like that's on it, we'll do that. And I was looking to see what people were doing for speech synthesis on device. And the model that I settled on is called Piper. And it's a quick pip install, Piper-TPS install. And it has access to a whole bunch of neural voices. And the voice quality is actually pretty good for what it does. So that was the easy part, getting it on there. And then I ran into some complications. I'm not going to bore you with all of them because then I'll just be a complainer. But among the challenges that I ran into were starting with Python 3.12, which is the default Python version on Ubuntu 24.04. Back in the good old days, you could pip install any Python package anywhere and it would just allow you. ROS is built on that. So there's a whole subsystem of specifying Python packages in your build file that it could pull in through pip in the background. That all breaks in 3.12, which is the default Python version. In Ubuntu 24.04. It breaks. When you try to do a pip install, you get a nasty warning saying you cannot install if you use this big nasty flag called --system-packages. You can overwrite it. Yeah. And so I've gotten pretty good at virtual environments.
Well, like I always use Conda, like mini Conda and all that working in.
Yeah. So virtual environments, you would think, okay, let's use a virtual environment. So getting this running in a virtual environment, lickety split, 3.11, 3.12, doesn't matter. ROS, Jazzy, under Ubuntu 24.04, only uses the system Python version. And it doesn't support virtualization at all. And so after you use the break system packages flag to load it, you find out that one of its co-packages, Piper Phoneme, doesn't even have a precompiled version for 3.12. So you've got to compile your own version, compile from source, and it's only a couple of statements, but you've got to figure out how to do it and use a PR that hasn't been accepted yet. And then you find that it uses a custom version of the eSpeak library that apparently doesn't get compiled and pushed over. But then you find out that just last month, the version of eSpeak that previously required a custom version was now baked into it. So you custom compile a version of that. And after all of this, you can get it running under ROS on 24.04. So I'm not going to cry about it anymore. It totally works. The voice that I'm using, because this whole guy at his best, he's going to be about as useful as a 5-year-old. And it just didn't seem right to have like a Jarvis type voice coming out of him. So in the list of neural voices for Piper voices, there are in English US, there's a whole bunch of different libraries. The one that I'm using is library tts.r. It's a re-rendering of it. And in this one voice, in this one small model, you have 903 total voices available for it. Now, so I wrote a Python script that said something interesting and recorded them all in the background. It runs faster than real time. And I got through about 65 of them before I settled on the voice that I wanted. So I do have 840 more at some point, but I wanted an androgynous, childlike voice. Robots really shouldn't be male or female. I think that's a little bit odd. But something childlike to set expectations and to not weird me out when I talk. So, voice 65 is the voice that I settled on. I adapted something that I found on the internet to load the voice up in Resident with a small subscriber that if you send a ROS message with some text, it will say that. And after vibe coding with ChatGPT to figure out how to make this into a ROS node and how to make a ROS file, that's about 10 times more complicated than ROS1. And I keep forgetting how to do it. Not complaining about that, not upset about that at all. Got it done, working. Support groups, we alternate Thursdays. Survivors of ROS 2.0. There's help out there, it gets better. We launched the ROS file. I'm subscribing to the logging facility in ROS so we can see the messages that they come through. And after all of that, we can craft a quick message to say something. And let's find something on the internet to paste in so that, let's see, should have had this queued up. Sorry about that. There we go. Here we go. Here's our, what we're going to have them say. Let's go ahead and clean up the text a little bit so that, we'll give them something a little more. He's always wondering how you're doing. Always. So let's get rid of that. We'll have full volume. Get on my Windows. So right click, Control V. There we go. There it is. And if all goes according to plan.
Our primary goal is to promote and advance the art of robotics surrounding technologies by providing a fun and exciting meeting place where people of all ages and from all walks of life, from the novice to the large brain pocket protector wearing robot guru, may gather and exchange knowledge, information, and ideas.
Hey!
Sounds like a female adult.
It does. I got through 65
Yeah.
and I gave up.
But 753 is better.
So I have a ROS subscriber that when you publish a message with text, I have two parameters. What is the text and what is the volume? And it just spits it out over the speaker. There is about a 1 second, it looks like a 1 second spool up, but that's actually the Python immediate mode, getting it ready and saying it's about a 1/2 second lead time. The voice isn't perfect. It's easy to figure out that it's not a real person. So it's not state of the art compared to what we can do right now on a dedicated GPU, but it's good enough. So for the next steps for this, so when you've got a robot with a lot of moving parts, and you can see on the left here is I have placeholders for a lot of modules. This is a full computer. I've got a placeholder for a land graph agent, automatic speech recognition through Whisper, that back module we talked about today, for bring up and tools and for running the LLM messages and TTS, is that it can't do everything all at the same time. So generally speaking, if you're talking, you don't want the speech recognition to work. If someone is talking, you don't want to necessarily run the speech module. And if you're thinking, all bets are off, don't do anything else, right? So there's a type of a ROS message called an action that I'm thinking of trying to use. I haven't chanced to use for it yet. So that way, when you're talking, the rest of the system knows that you're talking to not do some other things. And then you also know when talking is done. And in addition to that, it gives them a way to interrupt. Like you're in the middle of saying something and you're about to fall over. Well, maybe stop talking. So that's probably the next step for the module. And then after that, I'm going to look at using that Whisper speech recognition module. So at the end of this, LLM agent, some small subset of kind of what Zeph is demonstrating about giving the robot the ability to do something for tool use. And it should be able to talk about it and then take feedback from the user. So that'll be coming up over the next month. And then after that, if I say it out loud, then I have to do it. That's the rule, right? So all of this I'm getting excited about is because of NVIDIA Groot. That NVIDIA framework for humanoid physical robots that are free to download. It uses reinforcement learning and it has the entire tool chain to get the robots to do interesting things. And this is the reason why you're seeing humanoid robots being useful. This is the toolkit. So I'm going to start small because I need to get some experience with the toolkit. So the first thing that I'm going to do is I'm going to train Alfie to give high fives. So in order to do that, he's going to be teleoperated, and I'm going to record about 20 interactions. So hopefully next month, I'm going to ask you guys all to get in a line and give him left-handed and right-handed high fives. I'm going to teleoperate the hands in position, and it's going to record the video and the positions and the feedback of the forces. So I'll have 20 examples. 20 examples does not a reinforcement learning policy make. You have to have tens of thousands of examples. Luckily for us, NVIDIA has a whole toolkit to take a small number of real examples and to synthesize tens of thousands of more. So they have all the pieces. So at the end of all this technology and all this consternation and gnashing of teeth, I should be able to train a policy that he's going to see you walk up, put your hand up, and he's going to walk up and he's going to slap your hand. All of this to give you a high five. But this gives me experience with the framework so that I can start looking at what I can have it do next. At his best, he's going to be able to give you a high five, maybe take something from your hand, maybe leverage some of Jim's insights into pointing at something and having them figure out what you're pointing at, take something to the kitchen, take this person. Again, 5-year-olds aren't that useful. I don't expect him to be more so, but this is a perfect framework to explore those capabilities. And I'm looking forward to sharing those with you in upcoming months. All right, thanks.
All right, Ross online. Can you hear us?
Here. Hi from the north.
Hey there.
Some of you may recall I'm here via the Homebrew Robotics Club. I'm based nominally in the San Francisco area, where I joined. I'm almost embarrassed to say how long ago it was, but it was when the TurtleBot was first introduced, which is around 2010, and I actually still have one, which I'm in the process of upgrading to a new version of Jazzy 24, and Ubuntu 24 and ROS 2 Jazzy, as part of a team that includes Camp, PV, Alan Fetterman, and Thomas to provide menus or suggestions to customize your robot to what you want. Anyway, that's just to answer Alan's question. That's partly what I'm doing right now. But the most interesting thing, and since we're almost out of time there, I ran across a description of a kind of a cool design that I want to show. Want to give everybody a quick look at. It appeared, I think, as an announcement in discourse.ros.org, and let me just share my screen and let it talk to itself, talk to you about itself. And as if I didn't have enough to do, I decided to actually try it out. So this is called, let's see, I want some videos to work. Isn't there an option for that?
When you share,
yes, right. So I guess I don't know if this is going to work. I didn't click that button. Anyway, the designer has this just launched, as you can see here, a package that is quite unique in that the robot entirely uses an ESP32. Let's see, I guess I can highlight that. Right here, somebody mentioned just before me, and ESP32, which is an extremely powerful controller that has a lot of capability, and can be provisioned with the Arduino IDE. Well, I actually had an ESP32 in the back of my places where I put stuff that I'm no longer working on. I guess which we all have. We got way too much of that kind of stuff. And I had a chassis that used to be a different kind of robot that I probably had about 10 years ago, and said, "Hey, I'm going to give this a try." So let's put the camera on. I'll just show you how far I've got with this. Let's video. Oops. Ross phone. There. Okay. This is sort of tricky, but right, there's a most of you will recognize that being as a diff drive robot with two wheels connected to two motors, a battery on the back, and this is the cool part, is this, which is the ESP, hard at work, with Micro Ross. Somebody mentioned Micro Ross. Yes, the designer of this this platform has a GitHub that has the code that the Arduino sketch code that you would load in there. And then, of course, you're all asking, well, what about how do you run the robot? Well, that's all on the desktop. And the interesting thing about this designer's work is that he's released, disconnect, he's released am I back? Okay. Am I still sharing? Yes. Okay. He released a Docker that includes the ROS2 that's required to make it a ROS2 robot, but also all of the packages that interface with the robot and make it do the things that you want it to do. Now, I don't use Docker myself, and but I've always been, I guess like many of you, I've been curious about it, and it certainly offers lots of flexibility in implementing something on different platforms. Well, the neat thing about this person's design is that he's got a Docker that can be loaded onto a Windows machine, the Docker which has the ROS, actually it's Ubuntu, he's using Ubuntu 22 and ROS Iron, which is actually a discontinued ROS, but it doesn't matter because when you load and then launch the Docker either on a plain old Windows machine or your Ubuntu machine, and as it doesn't matter, and it actually doesn't matter whether it's a Ubuntu 22 or a Ubuntu 24 native machine or host machine, the damn thing works. And so I was, let me just run a quick video that this person, I hope this works, that is, it just frankly gives a quick, gives the better introduction than I could do nattering along here. Let's see how to, oops. There.
No, we're
Does
not
this work?
not seeing it. You gotta, I would quit sharing and then find that button when you reshare.
If you reshare your window, there should be a checkbox visible on the window that says.
Yes, that's right.
As well as share audio, if there's audio you want to.
Right. Exit, click. Oh, there. Okay. Yeah, that's right. I know they've moved that box a year or so ago, and I forget where they moved it to. But let's try again. Okay, there's a button down here that says layouts and options. Oh, there it is. All right. Sorry. You can see it now? Or you can see something. Right.
Hello. In this video, I will assemble a little Arduino ES.
Is that okay?
No, when you went full screen, it stopped.
Pardon me?
You clicked the full screen button, it died.
Oh, I guess, oh,
Maybe don't
okay.
bother, I guess.
Okay.
Just go to theater mode. Theater mode is always safe.
Motor cables. Unscrew all board wire terminals.
Anyway, I think the purpose of my little talk here was just to introduce this cool device, which implements.
Plug the breakout cable into the LiDAR sensor.
Which implements a Ross robot on an inexpensive platform, and it runs it loads the Ross to full navigation on your desktop. In the process, you actually get to learn a little bit about how to work with. I guess I should show myself. How you can use a Docker container that contains the ROS plus the code that runs the robot. So I've got the Docker actually loads very easily. His scripts are well designed to run, and within like 10 or 20 minutes, you've got a ROS on your desktop, which many of us are aware to get all the pieces that you need to get a robot working, meaning the navigation, the launch files, all of the particulars that are related to the specific robot you have. That's a piece of work. Anyway, he's loaded all of that into his Docker. You run the Docker, and then you can run your robot from your robot desktop, but you're doing it from a terminal with terminal commands, of course, from inside the Docker. Which I guess let me just do a see this. I have the thing running here. Let's see, where is it? This is getting too complicated. I'm going to stop now. I actually have my robot connected to my desktop through a Microsoft remote desktop that shows the terminals with an example of running the Docker. But that's a lesson for another time. So let's just go back to the. I'll just put his website back up for one more time for you to have a quick look at it. Where to go? It's this one here, I guess. And it's his documentation is really quite good. He's got four different models, physical models that are defined in a series of GitHubs. You can choose the one you want. There's a whole this, I think this was launched only in February, so he makes reference to a community of people, and I have found he's very responsive to answering questions that come up. I usually get it when I ask, how come this thing gives me an error message? I get an answer back within a day or two, which is of course always nice when you're working on something. So there we go. There's the website, makerspet.com, and his GitHub is KAI is this. Right. So there's there's where his code resides. Some videos to provision it. Oh yeah, and I'll just a final thing is he's written it to work with a variety of lidars, all the usual suspects, the RP lidar A8. The one I ended up buying, I actually ended up buying this because I happened to be able to get it at a good price from a local supplier on my side of the border. This is a YD lidar, and it sits on top of the robot. A variety of motor drivers that he describes in some of his commentary. It takes an LN298. It's described as an IN1, IN2 robot, where you put PWM on that pin. So there it is. This is a tell, not a show. So maybe next time. But it's kind of cool. It was a nice distraction from the other stuff that I was doing, and just that I was able to basically repurpose a whole lot of stuff I had, and play and give me some experience working with the ESP32, which is of course connected from the robot to the desktop using the Wi-Fi that's part of the ESP32. Sorry, I don't have a block diagram or a PowerPoint, but I hope that was an interesting illustration of kind of an innovative design that's very inexpensive. The ESP, of course, is $10, and not to necessarily promote his own little business, but I think you can buy the whole 3D printed base, the motors, and the ESP for as shown here for about 100 and something, 120, 150, depending on what it's equipped with. Ta-da!
Thank you, Ross. Right on. Thank you, Ross.
Yeah, it's cool. It's sitting here blinking away, and I've got the motors working. I have the ROS working. I can type usual ROS inquiry commands into the desktop terminal, and it tells me and it gives me the responses back from the over the micro ROS protocol, which is kind of cool. But the motors don't work yet, or the teleop doesn't work. Teleop doesn't work yet, for probably all of the usual reasons. There's something that's not quite set right.
One thing at a time.
Next month, man.
Yes, that's right.
All right.
Good. Anyway, it's by the way, just great material today, folks, and always good to see that what things that are an inspiration to it, and all the rest of us in putting together clever things that do fun things.
Yeah, always happy to have you, Tim. Ross. And next up, Trish.
Okay.
Oh, yeah.
Join Zoom. Just make sure not to share your audio.
Okay.
Hey, Tim.
What's going on?
Good to join us.
Oh my
We actually had someone here that wanted to meet you.
Yeah, I'm sorry. I'm still having transportation problems.
All right, so Trish, are you getting ready?
Yeah, so Patrick,
Does he have any questions he wants to ask?
you guys can talk after the show and tells?
Okay.
Patrick,
Hi, Alan.
Can I maybe show on this camera?
yeah.
Does that work?
It's a 360, so you're over there.
Okay. Can it zoom in on me? I got this little screen. I'm not sure if y'all can see. Oh, can I hold this up? It's this?
Yes.
Oh, wow.
The one on the side.
Oh, yeah, there's that.
Okay. Let's see.
Pretty good.
Back it up a little bit.
Yes.
There you go, right there.
Okay, yeah, it's doing some thing. So I'll show you the part and then I'll explain the project. Uh-oh. I think I have to hold it in front of my face because it's gonna pick up on my voice.
It focuses on where the voice is coming from.
Yeah, so this is a little screen. I could send in messages via Bluetooth out of this little chip. Just this morning I did that random color flash. And then there's kind of this meme from Dragon Ball Z. I don't know if any of you know like the over 9,000 thing. So I made like a little power level thing where I can send it a number and it counts up the power level.
That's cool.
So yeah, this is part of a wearable headset that I'm putting together. And I have a little video of the 3D print of that. Let me see. Oh yeah.
Making a little heads up display, it sounds like.
Yes. So kind of like a little heads up display that I can, oh, maybe that's not the best one.
Little like Iron Man.
Cool.
Yep. So it'll clip to my hat. And here, let's go back. Oh, it's very difficult to show. Well, anyway, I guess the basic idea is it'll clip onto my hat and it's kind of like a little robot where it has a screen that can articulate so I can look at it and then it can flip around so I can show someone else. And then it could also retract so that the screen is not there. And the reason why I want to do that is, I don't know if anyone's familiar with the like latest headsets, like the MetaQuest, the Apple Vision Pro, maybe the Meta Ray-Bans. So I think my like what I don't like about those is they have pass-through augmented reality. So and there's other ones too where they like they project something on your eye. And it's kind of weird if you're talking to someone who has one of those because you're not sure, like, are they talking to me? Are they reading off like a teleprompter? Like, are they just watching a video? It's very unclear. And sometimes they're like kind of looking up in the corner and you're like, are you looking at me? And then also you don't know if you're being recorded. Like with the Ray-Bans, they have this little light. And especially if you're outdoors, like if you're not paying attention, it can be hard to tell. And I mean, there's a similar thing with the Apple Vision Pro. And I just wanted to make something for myself, really, that's very clear, like socially, like, hey, am I actually, am I looking at a screen or am I like paying attention? And then make something that I can also show. So it's not like I'm looking at something and I can't share it with the person I'm talking to. And then also I made it controlled. I put some buttons on it and it has Bluetooth on it. So I can send messages from an app. And I think the current direction things are going is hand gestures. And which is really cool technology, but it's also a little bit weird. And also you can't use it while you're working on physical things. I understand it's good for like if you're coding and you could just go like this and just gesticulate and make things. But like, let's say I want to you want some heads up display because I'm like wiring something, like, you know, I have wires in my hands. So it would be, yeah, it would be nice if like I had like a physical button on it, or I could just have a control panel that wasn't like some weird gesture that I have to remember. So that's yeah, what I'm working on.
Hey, that's cool.
Oh, what's that?
I'm not going to. All of these gestures.
Yes, like buttons are good.
Thank you, Patrick.
Or something real good.
Make your own little
Hey, you're up, Trish.
AI interface, yeah.
I'm gonna make it super easy, quick.
Like Iron Man's Friday.
Hold on, Tim.
No problem.
Okay, so I found this guy on YouTube. I don't know. I've been exploring the microbit to kind of understand like where I want to take it and what to offer as a learning platform for the youth. And I actually do like it. The reason I like it is because it presents playfully. as a toy. And that's really important, but understanding how people will actually accept it is, and whether you can keep their attention long enough for it to actually be useful. And then also to take the microbit into a project that I want to do. So I'm kind of very old fashioned in that I like these old timey coin operated machines. And this guy, Rusty Rocket, did this project to basically do a small animation on a toy that he had found. So I thought why is it, oh, because I turned off my
hack old electronic toys. For example, Zoltar's face, the eyes, they're actually an old Furby. So I haven't built it from scratch. I've taken some existing eyes, i.e. in the Furby, and controlled them using one of these. So I thought I'd do a little tutorial.
So he did a tutorial and then I was trying to follow it and it was a little tricky and I got something to work, but then I'm still kind of trying to make it work the second time. So that's kind of what I'm doing, but I call my project Zulta, and because Zoltar is taken, and I don't know where I'm going to go with it, but right now I'm just trying to make the motor go. There we go, that's it. Anyway, so for me, it's a very kind of personal learning thing because I'm used to taking a thing out of a box and following the steps that they do. And this is the first time I am trying to figure out how I want to use something other than following the exercises. So, a different kind of way of looking at things. I think you said, I got a 3D printer, now what can I do with it, right? And then you said something to, oh, I said it, now I have to do it. But the other thing is when.
Yeah.
Anyway, that's it. That's all I have.
Yeah, thank you, Charlie.
Thanks, Trick.
All right, last but not least, Brian, the new Brian. Oh, it's at the very bottom of our homepage, right after the description of today's talk. It says Joey Zoom, RSSC.org. Over at the bottom. The speakers.
Recording in progress.
All right.
Oh, go ahead and join the audio.
That's a good thing. Yeah. All right. Well.
Disconnect from the audio.
Just completely. So just.
Better on the air.
Yeah.
At the speaker.
Oh, we're gonna.
Oh, yeah, I know, it's weird, but it works.
Yeah. Yeah, my name is Brian. This is my first time here. Just met Ben like at the Maker Fair, invited me over. I didn't plan to prepare anything. So, but I did, I guess coincidentally, I am working on a portfolio stuff. So I do kind of have, everything's a mess right now because I use multiple screens. Find blocks. Oh yeah, because well, for one thing, we were talking about Chat GPT a lot earlier, and I was on that for 40 hours last week. I was like,
Oh, really?
yeah, specifically for image generation, and I've never used it before, and yeah, I was getting really amazed at how structured and everything. And there's definitely limitations too, because I feel like the each individual chat just starts like a new memory. And even though you have to like explicitly say to, save and remember this, like it's still kind of remembers like the wrong thing. Like for example, this yeah, sorry. Yeah, so I mean, this was so yeah, my portfolio kind of has like 12 spreads on it, each with like one specific thing, and kind of for the background, it's kind of like a lot of this stuff that I was gonna put on. I guess of interest would be the robotics part, which is kind of the first part. Yeah, we were talking a lot about, well, this hand thing over here I didn't bring, but I know, I mean, I was just inspired to build it last minute because I know Ben had one at the first. And then Mo the same, but I think Alan, you.
I don't recognize that design. That's not.
Yeah, I think it's a new one. Because I think your guys's had you said there's like a 2 strings, one for I guess flexing and one for extending.
Yeah.
But this one is just like I guess we got bungee cord cables that just automatically always pull it back. So you're just really just pulling the strings down each. But I mean, I could talk about this, but I think that I want to talk about that Chat GPT thing. Yeah, so I got some pretty cool pictures, and I was like really specifying, like the prompts for these get really, really long, and like maybe I was spending maybe like 30 minutes just to generate one. But using Chat GPT, you could really refine and get a really specific prompt.
Do you pay for it?
You don't have to, but I did because it's like $20 a month for the first plan. And it's because I think you only have like a 10 image generation limit for the free version, I think. But for this, there's like I think it's like 10 for every like 10 minutes or 5 minutes or something. And then but it's not really a problem because when you're actually generating, it takes like way longer to come up with the whole prompt and everything. But yeah, let me show you what backgrounds I got. So, I mean, I generated a couple different versions for each spread. You can kind of tell it's like it's same theme, but yeah, this and then from those I just like chose like one that I guess took the best. I was waiting for some
Like Bento.
yeah, so my prompt, I specifically wanted it to be kind of German expressionist. And also I was even describing to Chat GPT, it's like a person, like just how I wanted to lay out my portfolio and what quotes were gonna be where. And then she was giving me like ideas. And I don't know why I'm calling her she, but I guess I think of her as a she. And I also, yeah, and I came up with this weird system workflow with them. Because specifically, I think came up with this.
It is appropriate.
Yeah, we came up with this. So with this abstract art style, I guess you could have different types of geometries that are kind of predominant in it. So here. Oh yeah, so this one got kind of messed up, spiral. But yeah, again, asked Chat GPT, what are the 6 like main geometries do you think that predominate in these pictures? And they're like, oh, these are the main themes: angular, curved, spiral, blocky, fractured, chaos. So I just made them assign like, oh, it's gonna be assigned geometry 1, 2, 3, 4, 5, or 6. And so my original plan was to generate each example with a different geometry, and that's kind of why I have different variations of these Yeah, so like you could tell there's like a spiral, like the first one. But then I really wanted it to be really like abstract and simple geometry. So, oh, this one's really cool. Yeah, this one I was like extreme
Well,
distortion.
that was Big Fish.
Yeah, so this is yeah, so that's kind of one of the themes of my portfolio. It's kind of like Great Gatsby and Big Fish. So I was taking a lot of imagery from that and a lot of like subtle background stuff. But again, my portfolio is like should be about the substance. This is just stuff in the background. There's some more stuff.
So did you actually give it the words Big Fish?
No, it was
Can I do that? I doctor.
yeah, yeah. So I had to kind of say this one I wanted to have, so for the eye, the TJ Eckelberg eyes. If you actually say TJ Eckelberg, it gets too specific.
Who's TJ Eckelberg?
Which is it's kind of the name of the eyes in the Great Gatsby book. Yeah, and usually I think because they already have a lot of cover art and other interpretation that's already out there on the internet, and it just starts looking like that. But yeah, this was cool because I was like, oh, what are kind of Midwest farming themes? And then she came up with like what barbed wire fence and farm and yeah. Yeah, there is actually another thing I could show you guys.
So is that text from part of your prompt, or that text with those lines that?
Oh no, so that's
Those are you asked it to describe?
yeah. So let me see if I
Like you show, if you could show us some of your
yeah.
text. Be interesting.
Yeah. And again, it's like you have to find the right kind of memory, they call it. It's like otherwise, if you keep talking the same chat, I guess they have like a certain like
context.
I got
yeah, and then after a while, it just gets super slow as you progressively go and go. And then at the end, it's just like you've reached the limit for this chat. You need to start a new chat.
Or it won't remember if you keep.
Yeah, exactly. But if you specifically tell it to
memorize this.
yeah, remember this one thing, then it says it does, but I can't find it.
All right, guys, I gotta go. I'll talk with you later. Show you next month.
All right, thanks, Tim.
Have that guy give me a call. Send
All
you my
right.
contact. I sent you all my contact information.
I can't really find it. I had a good tab. I don't know where it went.
All right, bye.
Bye, Tim.
Yeah, but I could start it. Okay, let's start it.
Actually, all your old ones should be there.
Yeah,
In your
but
account.
then oh yeah.
As long as you have an account, that's the benefit of having.
Just gotta log in.
Yeah. I think it's here. Okay. So yeah, I know for a fact if I like ask it like show me a prompt, one of our previous prompts in here as a new chat, it's gonna be different than if I go back on the actual session we were working on it, which I think was probably down here. The image generation tips and stuff. We talked about. Yeah, I asked a lot about ChatGPT, how it was pretty cool. But
But do you copy out your good prompts that you got into a separate file? Like
here, so
save them for good.
basically what yeah. So I actually pulled it to start this table over here to just collect stuff that we did. But then it kind of just really wasn't accurate and the memory kept So I just gave up on it after a while, but I was trying to, definitely. But okay, so I was saying like, spread 5 prompt. And then let's see, first. Yeah, so I had a lot of problems with getting the size to be 11 by 17. So I was like, emphasize it, say it 3 times at the beginning, in the middle, because every time you ask it to generate something with whatever, like this prompt, you would think that if you were to take that prompt again and then put it back in, that it would be a different, because it's kind of regenerating on the spot, but there actually isn't, because they have some like biases that kind of carry over, even if there's like they're generating a new one, even though, and then there's so many like, we were going back and forth for a while for how to really reset the thing. So I think I came up with a set of rules for it to follow, which was to reword things, use metaphors, also the order of things you put in.
So you're having it work on the prompt itself and vary it.
Yeah. Because it's like there's an intermediary, because I think there's like another image generation bot or whatever, and it's like seems like you're talking to someone to talk to somebody else.
Yeah.
And then even they're like, hey, yeah, I'm sorry that didn't work. The other person, blah blah blah. But anyways, it was just really confusing. Yeah, but this is like a typical prompt. Let's see, spread one.
Well, you told it to save these ones under spread
Yeah.
one. I haven't done that.
Yeah, I did. Yeah, if I could find that. So, it's on here. Just. Yeah, I'm finding it right now.
Oh, I saw your self file.
I
Here it is.
apologize for having this sentiment, but when I look at the AI generated images, I can, and maybe it's because I know that they are generated by AI.
Yeah.
I can feel that it's not generated by AI, that it's not created by AI.
Yeah.
I don't know if you guys have that sense. It's a bias for sure.
I noticed that on just like pictures. I don't know if they were AI or not. I look at a magazine, or you can tell they're being used in magazines and newspapers, because you look at it going,
yeah.
I got 6 fingers.
What's that?
Like, that guy had, yeah.
Well, that's an obvious one. Like, guess this.
I thought he has 4 legs.
What's that? Or
Like, that guy has 4 legs.
yeah, that too. But I mean,
When it learns to put the mistakes in, that's when it's gonna be scary.
yeah, I kind of think,
You don't notice the really good ones, so you only notice the bad ones.
Yeah.
well, I'm saying like on the
It's a delay
average.
effect.
The average like journalist or whatever, they're typing in something quick and just getting a picture. They're not doing the real refined work. But to me, it's reminiscent of me of Mad Mag, for some reason, Mad Magazine, that comic book. The way the artist did some of those of people the AI reminds me of that. So it's when there's people in it, like the animate, sort of a cartoonish look.
Yeah.
Not the photoreal, but
Yeah. Yeah, I mean, so I definitely took a while to refine it down to that point. When I was like, simple geometries.
You should get it to add texture to the
Yeah.
elements. That'll probably kind of
Yeah.
obscure it.
So I mean, this was the kind of the behind the scenes memory I was trying to get it to, note down. And actually, like, so for some of the spreads, I have like a different quote on, and it kind of took that sentiment from the quote and gave me suggestions on, oh, this one could be more dreamlike. So let's use the geometry spiral instead of the fractured sharp angle ones. And yeah, it was really, really crazy. So I try to get it to like note these down, but then again, like it just kept misremembering things and recalling it incorrectly. But yeah, after a while, I just started just doing it myself. But and then I just settled on, all right, generate one at a time, and then save it yourself, and then start to get a new. But yeah, that's my portfolio. There's another. I think in my old portfolio, there's actually something that's pretty cool that I worked on a while ago. Why am I not remember everything, but yeah. This is my whole portfolio. So my background's actually like in medicine and stuff, but after engineering, this was a project where I kind of made like a portable EEG machine. Basically, there was this like toy in the early 2000s or something, where they came out with these headsets. One of them was called Mindflex, and there was like a Star Wars horse trainer one. Yeah, yeah. So there's a thing where you could there's like a good tutorial thing, but yeah, pretty much opening it up, resoldering things. And I
Things were.
let me see if I have more pictures.
Homebrew EEG.
Yeah, didn't Walter bring one of those in a few years ago?
Yeah, he had it where you used to control a robot from thinking.
Yeah.
Or yeah, kind of. I mean,
Did he actually get it to work?
it's like kind of a little, just barely.
It could have gone.
Yeah, barely, yeah. So basically, how the EEG works, just in general, they have like, they map out your brain. And let's see, I'm trying to find a good diagram.
Yeah, the real ones are very expensive.
Yeah, so this one only had like 3 electrodes. And oh yeah, so this is like a good like the 1020 system or something. Yeah. So this is like a lot of electrodes. But yeah, this one only has like 3. There's like 1 in the center and then the 2 ear clips on the side. And oh, here we go. Okay. So, oh, and I made some like headers for my Arduino to just fit in. Yeah, and then this is it kind of running. This is through processing. So basically, EEGs when you kind of, so this Arduino on top, processing on the bottom for the visualization. Basically we have like 4 main brain waves, like alpha, beta, delta, gamma. And mainly the concentration one, and they have some proprietary like algorithm that they won't even release. But they make this separate band called like attention, which is usually the beta waves. That's when you're like most alert during the day, like also during like REM sleep too, when you're kind of mind's awake versus like you're in deep sleep or sleep, then you have like slower like brain waves. But yeah, somewhere in the code there was I think there was just like a value for like a threshold level. But I also wanted to maybe control something. So I made it like a plant water using the headset. So 3D printed this peristaltic. This is a very common 3D model, but with the little holes on the side, you can make it into like a peristaltic pump. And yeah, I mean, this is just like a cool project I did like a couple years ago.
So you made it water the plant?
Yeah, you just take that threshold, and then I would just like, all right, activate the motor. Absolutely. Yeah, but that's basically it.
All right. What I like about this is, aside from, in addition to the content, is this is a great example of partnering with the AI towards some common goal, right? You're answering questions, you're ripping off of each other, evolving it to come up with something that may be a little bit, pretty cool compared to at least what I'd be able to do on my own. So that was a good demonstration. Thank you. Yeah. Thank you, Brian.
All right, so that was the last show and tell.
So you came to a
And,
place with many clever people.
We will stop the recording now.
Thank you.